You ever come across a question that is asking you to write the relationship between the Cartesian coordinate system and the plane polar coordinate system and the classical mechanics? Well, let me simplify this for you so that we can see the relationship. Now, when we talk of the rectangular coordinate system, this is what we're talking about. We're talking of the relationship between the two and how can we come up with the coordinates and so on. So let's call this one our x-axis, because we assume that this is the rectangular coordinate system. Then on the same graph we can put the plane polar coordinate. Remember that under the Cartesian we have x comma y, right? And under the plane polar, we have what? R comma theta, the angle of rotation. Now, if I draw a line from the origin or from the pole, okay, to some point, that line is just the magnitude vector r, and this angle here is an angle of what? Rotation. Now I'm explaining this one in same thing as in mathematics, but here we are talking about the particle motion in plane polar and rectangular coordinate system. We see the relationship which they share. Now, at the same time, you know that the x-axis is assigned what? The unit vector what? I, and the y-axis is assigned the unit vector what? J hat. That means that leaves us with this scenario here. Here, this axis is also called the I hat axis, and this axis is also called the J hat axis. Hope it's making sense now. Now we know that the x-axis or the I hat axis in terms of this theta is related by cosine, right? That means here we have what? I hat cos theta, and here we have what? J hat sin theta. Now what is this coordinate here? Now if I take J hat, remember these are unit vectors, right? So this is my unit vector here. Let me do this. This is my unit vector J hat, and this is my unit vector I hat. That means I'm also going to have some form of a unit vector R hat. And in terms of R hat, J hat, and I hat, what will be my coordinate here? So my coordinate will be equal to R hat equal to, we always start with the x and the y, but it's a relationship just in terms of hats. Let me say the magnitude what? The unit vectors in short. So we have I hat cos what? Theta, comma, J hat sin what? Theta. This is a coordinate, this point here, in terms of the polar, the plane polar coordinate and the rectangular coordinate system. This is the relationship they share in that point there. Now, if we try to rotate the same axis, all right, on the other side of the graph, let's say, remember that in the plane polar coordinate, we've got only the axis to do with the magnitude and the axis to do with what? The angle. The same axis here is also to do with the angle. The same axis here is also to do with what? R at the same time. Now, if you rotate, assume you are rotating. So if I rotate this one by this angle here called theta, all right, so I rotate it. So this axis here, I'll rotate it for an angle of the same type there, such that I can have this type here. Now, rotating this one becomes theta what? Hat. It's now a unit vector the moment I rotate it. And I can have this. Now, when I rotate the j-axis, where is the j-axis going to find itself? You discover that to come somewhere here, right? And because you're on the opposite sides of the graph, this would be negative what? I hat. But is it still carrying sign? So cosine? No. We have rotated it in the opposite direction. That means the angle we are dealing with is no longer this one here, but this one here. That makes this one the opposite, and this will carry sine theta instead. What else? Then here we are going to have j hat cosine what? Cosine theta. It's a rotation, so you do the opposite. Hope it's now making sense. So this angle here is out. This angle which is here, just helped us rotate this one. But in simple terms, the angle that we are dealing with is that one there. Remember, the angle should be opposed to what? To sine, right? So even here is opposed to sine. But here, because it's in the negative axis, we can't change I to j. I remains the way it is. Now, what would be the position here, the coordinate? The coordinate here, we are saying it will be what? It will be theta hat equal to what? The x coordinate, it is negative I hat sine what? Sine theta, comma. Then the y is j cosine what? Theta. Now, let us write these as normal coordinate. Now, summary. So we have r hat is equal to I hat cos theta. Now, because we're talking about the relationship, it will be plus j hat sine what? Sine theta. So this is the magnitude of r and the magnitude of I and j, the relationship which they share. What of the angle hat, the theta hat? What's the relationship in the plane polar coordinate and in the rectangular coordinate system? So you discover that that will be what? Negative I sine what? Sine theta plus that cosine what? Cosine theta. This is a position, that's the angle, and remember that we only need this, comma this. Therefore this, comma this is this here, in this part here. That's all that you need to know. Then from here you can start now finding the velocity, the acceleration, magnitude of whatever. The moment you know how to come up with this, then it becomes easier for you.